Okay, in this video I'm looking at an introduction to compound interest. So I'm looking at this in the view of grade 9 and what we need to know for grade 9 regarding compound interest. In grade 10, 11, 12, you look at compound interest in more depth and look at compounding in other time periods other than annually. We're only going to look at annually today, which means per year. So when we're looking at compound interest, it means that if we have a loan or if we have an investment, that the interest is calculated for each time period, added on, and then calculated again each time, so that as you are increasing, as you are going through the time periods, you're getting more interest that you are earning over time as the amount gets bigger. So having a look at this example here, we're going to use a table to calculate the compound interest. So we've got $10,000 is invested at 5% per annum, compounding annually. So I'm changing my 5% to 0.05 so that I can find that out each time. So in the first year, you start with 10,000. The interest in that first year is going to be 0.05 times 10,000, which is the 500. So at the end of the year, you add on the 10,000, add on the 500 to the 10,000 and get 10,500. That becomes your new starting point for the second year. So instead of starting with 10,000 like we did at the start of the first year, in the second year, we're starting with 10,500. So then when we do 0.05 times 10,500, we can get our calculator and do 0.05 times 10,500. And we get 525. So we've gotten more interest in that second year than we did in the first year. Then we're going to add that on to our 10,500 that we started that year with and get $11,025. That then comes down to our number that we're starting the third year with. So then we're going to do our 0.05 times that new number, 11,025. So when we times that by 0.04, we get $551.25. Sorry, I wrote that in the wrong spot, $551.25. So then to get our total at the end, we need to add that $551.25 onto the 11,025 that we had at the start of the year. So we get $11,576.25. That's then going to come down to that next line there. And we're going to multiply that by 0.05. And we get $578.81 and some decimals. And we'll add that to what we started the year with. And we get that $12,155.06. So I know what you're thinking when you're seeing this. You're thinking, gee, that's taking a long time. I don't want to have to do that every time. And that's why we've come up with a formula to work it out, instead of having to work that out each time for each year. And then if we wanted to do that, so we only did for 4 years, if we were doing that for 10 years or 20 years, that's a lot to write in our table. So that's why we want to learn this rule instead. So our rule is A equals P outside of 1 plus I to the N. Our A is our amount at the end of the time period that we're allocated. So in this one, it will be at the end of 4 years. Here we've got our P, which is our amount that we start with. Then we've got 1 plus I, so it's the same I we used up here in our table, the 0.05, and we're raising it to a power of n, which is the number of compounding periods. Now, you're only doing annually, so you could basically say that's the number of years for n, but when you get further into compound interest, you'll be looking at compounding monthly or quarterly or daily, and so your n will be determined by how many compounding periods you have. Your I will also change based on that, but because we're only doing annually, we've got our number of years and our I is 0.05 there. So we can have a look at doing that with that question that we looked at up here in our example in our table. So each time I always write down my A, P, I, N, and I put in what I know. And I don't know my amount. That's what I want to work out. I'm starting with 10,000. I've got my 5%, which is 0.05, and my 4 years. So over here in my formula, I'm writing my A equals P outside of 1 plus I to the n. I've got 10,000 outside of 1 plus 0.05 to the power of 4. Now I can put that into my calculator. So I can type my 10,000. I can put a bracket. I can put 1 plus 0.05 there, bracket, and then use the little up arrow. Using the little up arrow, I can raise that to the power of 4 because I'm doing it for 4 years. When I press enter, I get 12,155.06, which happens to be what I got in my table, and I've written there on the page. Then I've got another example to have a look at over here using that rule again. And this is one where we definitely wouldn't want to have to set up a table for, because we've got $10,000 is invested for 15 years at 6% compounding annually. We want to calculate the amount at the end and the interest that was earned. So we're going to start the same way as we did before. We don't know our amount. Our principal is 10,000. Our I is 0.06 because we had 6%. When we divide that by 100, we get 0.06. And our N is 15. So I've written my rule here. So I'm going to fill in my 10,000 times 1 plus 0.06 to the power of 15. I'm going to grab my calculator. I'm going to pop that in, 10,000, bracket, 1 plus 0.06, bracket, to the power of 15. And I get, my answer is $23,965.58. The next part says, and the interest that was earned. Now, if I start with 10,000 and I finish with 23,965.58, how much interest have I earned in that time? Or if it's a loan, how much have I had to pay? So I'm going to do 23,965.58, take away the 10,000. So I'm going to get $13,965.58. So look at what you're being asked. Are you asked the amount at the end, or are you asked how much interest? So if you want the interest, you do have to find the amount first and then take away what you started with. Now you should be able to work on those questions from the textbook that are on compound interest for a number of years, and you're calculating either the amount or the interest that you have earned.